In this first chapter, we'll be talking about the motion in a straight line. In order to understand the concept of motion, we need to understand the basic fundamentals, which are the distance and the displacement. What's the differences between the distance and the displacement? The distance is the total length of the path travel, as it says here, the total length of the path travel. The unit of the distance is the meter. That's the SI unit. The distance is a scalar quantity. That means it does not have any direction. So it has only magnitude. It does not have any direction. And as the distance does not have any direction, it cannot be negative. It's only positive. So it can be either 0 or it can be positive. So that's about the distance. Now, the displacement. What is the displacement? It is the change in the position of the object. If you travel from one point to another point, the shortest distance between the 2 points, the starting point and the end point, the shortest distance gives you the displacement. Or in other words, mathematically, the displacement is defined by this formula here, where this is the change in the position, xf minus x0. xf is the final position and x0 is the initial position. And this is the delta x. This is called the delta x, which is the change in the position of the object. The displacement is a vector quantity. It means it has both magnitude and direction. As this one has the direction, it can be both positive, it can be negative, or it can be 0. And now I'll give you the examples to show the difference between the distance and the displacement. Let's say you are moving in a circle, all right, and you started from point A. So this is the starting point, and this is the final point. You started from point A and then you moved to the point B. The path and you moved along a circle. That means you started moving this way. All right, and you moved from point A to point B. In this case, you have to calculate what is the distance and what is the displacement. Okay, so the distance, the actual path you have traveled is all the way along this curved path, along this semicircle here. So this is the distance. In other words, the distance is the actual path covered. And if I need to write it down, the numbers, the way you have to write down is the 2 pi r divided by 2. The 2 pi r is the total circumference, and as we have moved only the half of it, it is divided by 2. So the 2 and 2 cancels out, then you have pi times r. The pi and the radius in this case is 5 meter. So what is so if you multiply them together, what you get is 15.7 meter. So this is the distance. Now let's calculate the displacement. As I mentioned, what is the displacement? The displacement is the straight line connecting the starting point and the final point. The starting point is this point A, and the final point is this point B. If I connect these two lines, so this will be the length of this line will be the displacement. All right, and this is the direction as well. So what is the length of the line connecting initial point and the final point, or what is the length of the line connecting the final point and the initial point? So it is the length of AB, which is equal to the diameter or twice of the radius. The radius in this case is 5 meter, so your total displacement is going to be 10 meter. So this is the one example. All right, so we have calculated distance and the displacement, and look at the numbers. The distance is 15.7 meter and the displacement is 10 meter. So the distance in this case is greater than the displacement. Now let's take a look at another example here. Now in this case, the particle or an object is moving from point A to point B, and then it is moving through the different paths here. The path is shown this way. So it starts moving this way and then moving this way. All right, now you have to calculate what is the total distance and what is the total displacement. So as by definition, the distance is the total path covered. So in this case, the total path covered is this length plus this length plus this length, this and this. So if I need to add them together, what I get is 2 meter plus 3 meter plus 2 meter plus 3 meter plus 2 meter. Okay, if you add them together, what's number you get? 5, 5, 10 to 12 meter. So the total distance is 12 meter. Now let's calculate the displacement. What is displacement? The displacement is, again, if you connect a straight line from point A to point B, then this length here, which is shown by this arrow here, gives you the total displacement. So let's calculate the length here. This length here, what is this length here? This length is 2 meter, this is 3 meter, and this is 2 meter. So the total displacement is 2 plus 2 plus 2. This 2, the first 2 is this length, the second 2 is this length here, and the third one is this length. So the total displacement is 6 meter. Okay, this is the second example. Now let's move to another example here. Now in this case, you start from point A and then you go to point B, and the path is shown this way. So you first travel from point A to this point, and then from this point to the final point B, and the various routes are shown here. Now you have to calculate what is the total distance and what is the total displacement. The total distance is 3 meter plus 2 meter, which is equal to 7 meter. This is equal to 7 meter. And now the total displacement. How do you define the total displacement? The total displacement is defined as a straight line connecting the initial and the final point. If I connect this point, this length shown by the red color is the displacement. So what is this value here? If you look a triangle, this is a right angle triangle, so the total length would be 3 square plus 4 square, which is 16 plus 9, so this will be 5 meter. So in this case, the displacement is 5 meter. If you connect the initial point and the final point, the length of the line connecting initial point and the final point is the displacement. Now, how do you find out the angle? So the angle is defined as this angle now here. Let's call angle theta. All right. So the particle has moved, or the object has moved from point A to point B in this direction, or at an angle theta with respect to x-axis, or with respect to the horizontal line. So what is this angle here? How do you find out the angle? Look at this triangle here. The tangent of theta is a rise over run 4 divided by 3. So the theta would be the tangent inverse 4 divided by 3. And if you just solve it, let me give you the number. 4 divided by 3 shift tangent inverse, you'll get 53 degree. So this angle is 53.13 degree. So what does this mean? That means the particle moves from point A to point B at an angle of 53.13 degree with respect to the horizontal line, and it has moved 5 meter. That's how you get from point A to point B. All right. Now let me give you one more example, the distance and the displacement. The particle in this case has started from this point A, and it has moved to the point B, and the path is shown here. How do you calculate the distance? So the distance is the total path covered. This is 2 meter, this is 1 meter, and this is again, and this is total is the 4 meter. 2 meter, 1 meter, and the 4 meter. 2 plus 1 plus 4. What you get is 7 meter. That's the distance. Now what is the displacement? How do you define displacement? The displacement is defined if you connect these two lines. The length of this line gives you the magnitude of the displacement. All right. Now we need to find out the length of AB, and then the angle, and this will give you the angle. Okay. So you see this is 1 meter. This is 1 meter, and as this is the total length, so this will be the 2 meter, because from this point to this point is the 4 meter, and from this point to this point is 2 meter. So this one will be 2 meter. So the angle, if you look at this triangle here, let me erase this one. Let me find out the angle. The angle now is defined as the tangent of theta, which is, in this case, P will be 2 meter divided by 1 meter. Then your angle theta would be equal to 63.13. We first calculated the angle. All right. So in order to calculate, so you just type 2 shift tangent inverse, you'll get 63.4, in fact 43 degree. And the displacement is a square root of 2 square plus 1 square, and it will be a square root of 5 meter. And the square root of 5 is 5 square root will be 2.236, 2.24 meter. This is the displacement. This is called the magnitude of the displacement, and this is called the angle. Okay. Now, the final example I'm going to give you for the distance and displacement is, let's say you're moving in a circle again, and you started from point A, all right, and you started moving in a circle, and then you again came to the same point. Your starting point and the ending point is exactly the same, and you moving in a complete circle here. You moved in a complete circle. Okay, so what is the distance in this case? The distance is the circumference, the 2 pi r, which is the length of a circle, the 2 pi r. So 2 pi and our radius is 10 meter. If you solve this number, if you multiply them together, you will get 20 times, which is 62.8 meter. 62.8 meter is the distance. And the displacement is, if you connect the initial point and the final point, in this case there is no length, because the initial point and the final point is exactly the same. So in this case the displacement is exactly 0 meter. All right, now let me give you one more example here. Let's say you have one particle, you started, there are two men, both started from the same point. All right, one object moved this way, let's say 5 meter, and another man moved this way, exactly the same length, 5 meter. All right, the one person moved this way, and this one, okay, let me change. So this person moved this way, and this person has moved this way. So now what is the distance? The distance for both, the actual path traveled by both men is exactly the same, which is 5 meter. And now the displacement, let's call this is A, let's call this an B. So for the displacement, the displacement of A will be negative 5 meter, and the displacement of B will be positive 5 meter. But the distance for both is exactly the same, 5 meter. And the reason is because it does have the direction. We can call this direction as a positive direction, then we have to call the opposite direction as a negative direction. So as you see now, the distance is always greater than or equal to the displacement. The displacement can be positive, it can be negative, or it can be the 0. All right, it is a vector quantity. Displacement is a vector quantity, while the distance is a scalar quantity. So I hope all these examples will help you to understand the difference between the distance and the displacement. Thank you so much.